Mass timber construction has gained significant attention in recent years due to its numerous benefits, including its impressive and unexpected fire resistance properties. In this video, we will explore the various aspects that contribute to mass timber's fire resistance, making it a safe and viable option for modern construction. Design flexibility. Mass timber construction offers remarkable design flexibility for enhancing fire resistance. Key advantages include the ability to add protective coatings to timber elements, significantly improving fire resistance by adding an additional layer of protection against heat and flames. These coatings primarily consist of intumescent coatings that swell when exposed to heat, forming an insulating char layer, fire retardant paints that release non-combustible gases when heated, and fire retardant sprays suitable for smaller areas or where a paint-like finish isn't required. If necessary, gypsum layers can also be incorporated into the design, further enhancing the fire resistance of mass timber structures. Gypsum board, known for its fire-resistant properties, can also be added to mass timber elements, creating a barrier that slows down heat transfer and protects the underlying wood. Gypsum layers do, however, hide away the natural beauty of wood, taking away some of its other benefits, such as the biophilic properties. The combination of mass timber and gypsum can achieve fire resistance ratings of up to 3 hours or more, often meeting or exceeding building code requirements. These methods provide designers with multiple options to achieve fire resistance levels, while maintaining the aesthetic and structural benefits of mass timber construction. Testing and standards. Extensive testing has been conducted to establish the fire performance of mass timber structures. These tests have consistently demonstrated that mass timber structures can often meet or exceed the requirements of modern building codes. For instance, successful fire tests have been completed on numerous mass timber elements and assemblies, achieving fire resistance ratings of 3 hours or more. In a recent series of large-scale fire tests conducted by the Canadian Wood Council, a full-scale, 2-story, 334 square meter mass timber structure endured a total of 19 hours of fire exposure across 5 separate tests. These tests were conducted without sprinklers and firefighting intervention to test worst-case scenarios. In a specific example of mass timber's fire resistance, Ash's MASSLAM, a range of mass timber components, passed Australia's first 120-minute loaded beam fire test. The GLT members were subjected to temperatures of 1000 degrees Celsius, while maintaining their structural integrity and load-bearing capacity. These findings collectively demonstrate that mass timber buildings, when properly designed and constructed, can provide excellent fire resistance and safety performance, often surpassing traditional construction materials and meeting or exceeding building code requirements. Thermal mass. One of the inherent advantages of mass timber is its thermal mass properties. Unlike some other building materials, mass timber doesn't spread heat quickly throughout its structure because of its dense cellular composition, which acts as an insulator, slowing the transfer of heat. This characteristic helps contain the fire and prevents the rapid heat transfer to other parts of the building. Additionally, mass timber's cellular composition slows the release of heat, which can be beneficial during a fire. This property allows for more controlled and predictable fire progression, potentially providing more time for evacuating a building and firefighting efforts. Moreover, evacuating a mass timber building is often more safe than evacuating other traditional building types. In steel buildings, for example, the steel components can become extremely hot during a fire, posing a risk of burns to individuals that might touch a steel staircase or steel construction elements. Predictable burn rate. Mass timber elements show impressive strength when exposed to fire, keeping their structure intact for long periods. This special quality comes from wood's natural features, which let it form a protective burnt layer whilst keeping the strength in its unburned core. Unlike steel, which can quickly become weak in high temperatures, Mass timber burns in a steady way that offers big advantages. This predictable behavior helps architects and engineers design mass timber buildings with a clear understanding of how they'll hold up during a fire. This allows the creation of effective safety measures and escape plans, making the building safer overall. To improve safety and performance even more, researchers use advanced computer models to simulate how mass timber buildings behave in different situations. By using these advanced simulations, combined with mass timber's fire-resistant properties, engineers can create buildings that meet or exceed safety standards, create the most efficient structures, accurately predict how buildings will perform in various conditions, and follow strict building rules. This approach gives a full picture of how mass timber structures will react in various fire situations, providing key insights for both design and safety planning. Charring Properties. One of the most notable fire resistance properties of mass timber is its charring behavior. When exposed to fires, the outer layers of wood begin to char at a temperature of approximately 300 degrees Celsius. This charring process typically occurs at a predictable rate of around 0.5 to 1 mm per minute. The char layer that forms on the surface of the timber acts as a protective barrier, insulating the inner core of the wood from heat and flames. This process significantly slows down the combustion of the timber, allowing it to maintain structural integrity for longer periods during a fire, thus allowing for more time to evacuate a building. Remarkably, mass timber can exhibit self-extinguishing properties. As the char layer develops, it can limit the amount of oxygen that can reach the burning wood, potentially leading to the fire extinguishing itself in the char layer. Less smoke production. An often overlooked benefit of mass timber in fire scenarios is its relatively low smoke production compared to some other building materials. This characteristic can be crucial during evacuation procedures, as reduced smoke levels allow for more visibility and better air quality, potentially allowing for safer and more efficient evacuations. Conclusion: mass timber's fire resistance properties, including its design flexibility, proven performance in testing, thermal mass characteristics, predictable burn rate, charring behavior, and reduced smoke production, make it a compelling choice for modern construction. As building codes continue to evolve and recognize these benefits, we can expect to see an increasing adoption of mass timber in a wide range of building types. Do you know someone who thinks that mass timber buildings are prone to fire because they're made of wood? Then share this video with them to highlight the fire resistance properties of mass timber. If you haven't already downloaded the mind map that includes all of the benefits of mass timber, head over to our Patreon page. There you can see and download the mind map for free.
Stay informed, stay inspired. TimberTalk.